Here, the identification of the presence of carbon in an organic compound. Hereafter, we are going to consider about the organic compounds. Basically, the hydrocarbons. Hydrocarbons are the compound having only the carbon and hydrogen. And if we have carbon and hydrogen in something, then we call hydrocarbon. You may have heard something about these in your O level, right? If you get organic compounds, uh, almost all the things what we use are organic compounds, means carbon containing compound. If carbon contains in a compound, then it contains hydrogen. Very rarely, there are few cases where the hydrogen is absent. Otherwise, almost all the organic compound means carbon containing compound. Basically, or mainly, if carbon contain in a compound, then we call organic compound. Why? They are called organic compounds at the very beginning of the development of this chemistry. They have identified that only these kind of compounds can be extracted from living beings, organisms like that. That's why they have named that as organic compounds. Organ, basically carbon containing compound, living beings. Now they have extracted many compounds. They have synthesized many compounds which are non found in non-living beings. And also, you know that any drugs what you get, any plastic, any cloth, any food you take, almost all are, if I get the 99%, 9999, organic compound means carbon containing compound. If you get our entire body, other than our bone and the nitrogen containing few compounds, the rest is organic. Nitrogen containing means definitely the organic compound, but minute amount containing the nitrogen, right? So, if you get the paper, plastic, cardboard, wood, whatever you get, all are organic compounds. So, the organic compound, we have the lessons. Lesson number 7, 8, 9, and 10. There are 4 lessons. Out of 14 lessons, 4 lessons are organic chemistry. Basically, you will get around 12 to 15 MCQs from organic. And also, I sent this, I think. I sent this note to all of you. Did I? Who asked for that? Okay, give me a second. I will check it and let you know. Right, then MCQs and one structured essay question and also one essay type question you will get. For this, you will get 7.5 marks out of 100. For this, you will get, sorry, 5 marks out of 100 for this. Fine. And here 7.5. That means here 12.5. And from this, you will get another at least 12 marks. Then roughly you will get 25 marks for organic chemistry out of 100. That means 1/4 of your syllabus is organic chemistry. Right? So it is very important. Later we will study that organic chemistry. That is very easy part because it has a pattern. If you catch it from the beginning, then it is very easy. Otherwise, maybe it's hard. But anyhow, we can make it easy. Right. Then identification of presence of organic, the carbon in an organic compound. How we can do it? We can burn. Any hydrocarbon can be burned. Right. So by burning that, the gas can be passing through a lime water, then lime water will turn milky because of the e- carbon dioxide gas. To evolve that carbon dioxide gas, there must be carbon in the compound. And also water will be liberated, so you can cool the sample of gas, that the liberated gas sample, then water droplet, the liquid droplet will be found. That liquid droplets we can touch with the anhydrous copper sulfate, then copper sulfate will turn into blue. So again, you can identify it contains hydrogen. Without hydrogen, no water can be formed. Right? So that's how we identify the carbon and hydrogen, presence of this carbon and hydrogen in organic compound. Right? This part is not in your note. There is a small part, but this part is included. The quantitative analysis of organic compounds. Here we are going to determine the molecular formulas of organic compounds. How we can do it? See, when we burn any hydrocarbon, say you have hydrocarbon, hydrocarbon means any compound having carbon and hydrogen. You know that CH4. CH4 means that is the carbon and hydrogen containing compound that is called methane gas. Methane, no, basically we know that it has the it is called the um, the biogas. Biogas contains the CH4. And in your gas cylinder at home, we have propane, CH3, CH2, CH3. The majority is propane and the rest is butane. Say CH3, CH2, CH2, CH3. These two gas, mixture of these two gases containing in your gas cylinder, domestic gas cylinders, it has this. Few years ago, we experienced some blasting of these gas cylinders because of this. The composition was, they have changed the composition. Then the composition was not actually suited to Sri Lankan climate and the other things, therefore that's why it happens, right? So anyhow, these are hydrocarbons. So you can see that only the carbon and hydrogen available in all these compounds. So what will happen if you burn this carbon and hydrogen containing compound in oxygen? See, you can mix this with oxygen and burn it. Then you will get CO2 and water. If you add excess of oxygen, why do we need this excess of oxygen? To ensure the complete combustion. Otherwise, you know that incomplete combustion gives us carbon monoxide. Carbon monoxide cannot be identified. Carbon monoxide cannot be identified by using simple methods. Right? That's why we need to ensure that the combustion is completed. That means all the carbon converted to carbon dioxide and hydrogen converted to the water. Then you can get, say, known mass or volume can be burned with known volume of this oxygen. Then at the end of the burning process, if you have mixed exactly the required amount of oxygen with this, see, one carbon, one CO2, four hydrogen, two water. Then how many oxygen atoms? Here you have two oxygen atoms. Here you have two oxygen atoms. So altogether we have four oxygen atoms. But oxygen contains two oxygen atoms in one molecule. So if you need two oxygen, four oxygen atoms, you have to multiply that by 2. Then you will get 4 oxygen atoms. 2O2 equals 4 oxygen atoms. Therefore, you can put 2 here. Why? We need 4 oxygen atoms when we balance equations, basically we check two things. First one is on both sides, left hand side of the arrow and right hand side of the arrow. On both sides, there must be same number of atoms. That is called the mass conservation. Mass conservation means the mass of the reactant must be equal to the mass of the product. The word here we have CH4 and this one. One carbon, four hydrogen, and four oxygen. Here you have one carbon, 2 into 2, 4 hydrogen, and 4 oxygen. Right? Then it is correct. That means this reaction is balanced. Just to balance that, we need. Say, if you have this one, say you have a compound C2H6. There is a compound with this molecular formula. If we need to burn it, then you will get CO2 plus water. How many carbon? 2 carbon means you have to have 2 carbon dioxide molecules. And because of the presence of 6 hydrogen atoms, here you have to multiply that by 3. Then the 3 into 2, you will get 6 hydrogen atoms. For that, we need 3 oxygen atoms here and 4 oxygen for this. Then altogether, you need 7 oxygen atoms. But now I need to convert that into molecules. One molecule contains 2 atoms. Therefore, you need exactly the half of the molecules as number of atoms. Therefore, you have to multiply this by 7 by 2. Here it is. So you can balance that equation. And if you have some other equation like say C2H4, again you can burn it with oxygen. Then you will get the CO2 and water again. In this case, CO2. CO2. There are 2 carbon dioxide, 4 hydrogen, 4 hydrogen. To get 4 hydrogen, you have to multiply water by 2. Then for water, we need 2 oxygen atoms. For carbon dioxide, we need 2 into 2, 4 oxygen atoms. Altogether, we need 6 oxygen atoms. Then how many water the oxygen molecules? 6 by 2. That means 3. So you have to multiply this oxygen by 3. That's how you balance those equations. But the problem is we don't know the molecular formula of the compound which we are given in our exam, right? We don't know that. So as we don't know, we are going to determine the molecular formula of that particular compound, what they have given us with some data. Then we assume that the molecular formula is something. I assume that in my molecular formula, I have X number of carbon atoms and Y number of oxygen, the hydrogen atoms. This may be CH4. Then Y equals 4, X equals 1. If I don't write any number, that means it is 1. Here 1. 1, 4. X equals 1, Y equals 4. If you have this C2H6, then X equals 2, Y equals 6. That's all. We have to determine. Therefore, as I don't know that, I just get this as my molecular formula. I take it as ACXHY. Then I add oxygen and burn it. Then we will get again CO2 and water. Now, as we have X number of carbon atoms, I must get X number of CO2. CO2. As I have Y number of hydrogen here, I must get Y by 2 of water molecules. Why? If you have the CH4, you can just compare this. Then oxygen, I burn it to get CO2 and water. As I have 4 hydrogen, if I multiply this by 2, that means 4 by 2. 4 by 2. I am multiplying that 4 by 2. Then I will get 2. 4 by 2 is 2. So 2 water means 2 into 2 water is the number of hydrogen atoms will give me 4 hydrogen. 2 into 2 will be 4. But in this case, if I have 4, I divide that by 2 and put it here. In the same way, I divide y by 2 and put it over here. Then I will get the number of hydrogen atoms equal on both sides. And carbon atoms equal. Now I need how many oxygen atoms here? 2 into x. 2x of oxygen atoms. Here I need y by 2 oxygen. 2 into 1, 2 oxygen atoms. Here 1 into 2, 2 oxygen. In the same way, I can now balance this by y by 4 number of oxygen atoms are needed. Y by 4. Y by 4 of oxygen molecules. Y by 2 number of oxygen atoms required me y by 2 into or y by 2. Now a 2x plus y by 4, y by 2. Y by 2 is equal to the number of oxygen atoms required to balance this equation. If I divide that by 2, then I will get the number of molecules. That means 2x by 2 plus y by 2 by 2 means y by 4. That means x plus y by 4. This becomes x plus y by 4. Right? That's what you get. Is it clear, Buddha? If not, let me know. I will re-explain. Otherwise, I assume that it's okay. Done, eh? Okay, good. Then, why we need this relationship or this balancing equation or balance the equation for future calculations. That's why I just wrote it. Right now, the quantitative analysis of organic compound. As I don't know the formula of the organic compound, I just assume that my formula is CaXHY. Then burn it with oxygen. Excess of oxygen. Excess of exactly the required amount can be mixed, then burn. Then you will get, as the product, you will get only at the end of the burning process, you will get the product. That product may contains only the carbon dioxide and this water. Carbon dioxide and water. And remember that here we are going to apply the Avogadro's law. Avogadro's law. What Avogadro's in? The same volume contains same number of atoms or molecules. Under same condition means under same temperature and pressure, equal volume contains equal number of atoms. We are going to apply that later in our calculation. Otherwise, actually, here is no way to get the formula. So here what we are doing is we just use that. Okay, then the quantitative analysis. Quantitative means determination of the amount. Quantitative means amount. Quantitatively, amount wise. Right? Quantitative analysis of organic compound. Here we are going to determine the amounts. How many carbon atoms, how many oxygen atoms, how many hydrogen atoms, how many nitrogen atoms, how many sulfur atoms, and so on in a given compound. Here, first step a known amount of a given hydrocarbon is thoroughly heated by mixing with preheated copper oxide in an arrangement as shown in the below diagram. Then the carbon dioxide and CO2 can obtain as the product. Then if you have this organic compound, you can heat that with CuO, preheated CuO. Then you will get carbon dioxide and water as the product. Then, why do we need this preheated copper oxide again? That the copper addition of copper oxide will ensure that the reaction will go into completion. That means it will burn completely and give us the carbon dioxide. If the reaction will never give us carbon monoxide. That means just to ensure that all the carbon turn into carbon dioxide. That's why we are adding the CuO. What happens really if you add the CuO? If you need, you can write down these things, right? Say, in case of, in case of, in our burning process, say, assume that it produces carbon monoxide. Then, if all the carbon convert to carbon monoxide, when we pass that carbon monoxide through calcium hydroxide solution, nothing will change. We can't identify that carbon dioxide or carbon containing compound. But if you pass this carbon dioxide through calcium hydroxide solution, then it will convert, or the carbon dioxide can convert the calcium hydroxide solution into milky, and this copper oxide can convert carbon monoxide into carbon dioxide. How? Say, if you have carbon monoxide, when we heat with copper oxide, it will give us copper plus CO2. This copper oxide is known as oxidizing agent. Copper oxide is known as our oxidizing agent. It can oxidize the carbon monoxide to carbon dioxide. Okay? That's why we use the presence of copper oxide ensure the complete combustion of carbon. That's why we are mixing that with the preheated copper oxide. And the other thing is, why do we need to preheat this? Because this copper has a special feature that means it can absorb water molecules from the surrounding. If you heat that before you use that copper oxide, once you heat, all the water associated with copper oxide will remove. Now you will get the dry copper oxide. Now you will get dry copper oxide. Right? Then dry copper oxide will mix with that hydrocarbon and oxygen, then heat, then it will prevent the formation of this carbon monoxide. That's why we add in this preheated copper oxide. Right? If you need, you may note down something, whatever you need. Then we pass this gas mixture, which we obtained after the burning, through this setup. Here you have the sample. You have the sample here. Then this sample will be heated with oxygen. See, oxygen supplies to the combustion chamber. Then it will burn completely. with the help of oxygen and the carbon, the copper oxide presence in this. Then the gas mixture, after the burning, the gas mixture will enter into this. The gas mixture will enter into this, the next part of the chamber. All right. Then once it enter into this chamber, we have magnesium perchlorate in this. This is called magnesium perchlorate. Magnesium perchlorate. Magnesium perchlorate can absorb water. See, it absorbs water. Then after passing through this gas mixture contains only the CO2. CO2 will be passed to the next chamber. And that chamber contains sodium hydroxide, potassium hydroxide, or soda lime. That means highly basic solution included in that. Why? This carbon dioxide is an acidic gas. So, the sodium hydroxide can absorb that carbon dioxide gas. Right? So, sodium hydroxide is a base, carbon dioxide is an acidic gas, they will absorb. But if you use the pre-measured magnesium perchlorate solution, then the sodium hydroxide or potassium, right? Then the sodium hydroxide will absorb the carbon dioxide. So if you have measured the mass before the experiment and after the passing of these gas mixture, then you can see or you can determine the amount of carbon and the amount of hydrogen present in that particular compound. Then here we have this, the preheated copper oxide and oxygen. Then we burn it in such a chamber as I showed you. Then this carbon dioxide, water is a liquid if you allow that to become room temperature. Water is a liquid, but carbon dioxide is not a liquid, it's a gas. So after the combustion actually, and we allow that right. Doctor, now we have this. Next one. As the gas leaves the furnace, the carbon dioxide and water vapor produced by the combustion of this reaction. The gas stream first pass through this desiccant, means the water absorbent setup desiccant. Typically, this magnesium perchlorate, which removes all the moisture. Then Once you pass this through magnesium perchlorate solution, you can get the mass of that solution. Then the gas mixture will pass through the sodium hydroxide solution, then carbon dioxide will be absorbed. If you have excess oxygen, that will come out from the system chamber. Then by measuring the masses of the liquid before passing through the gas and after passing through the gas, we're done. Then we know how to get the mass of this carbon dioxide and water liberated from this. Just assume that you have, here. Say you have 25 grams of magnesium perchlorate. But after the combustion and passing the gas through this, if this is 264 grams, then this much of milligrams of CO2 has been produced. Then you can calculate how much of the rest. The other thing is, uh, we measure the mass of this one. Say it is also 25 grams. Then we pass. Then you have 25 grams. Then after the passing through the CO2 gas, sometimes you will get 25.625. Means you have added some extra amount. Means now if you know the initial and now the final, initial and final difference will give us the mass of water absorbed by that. Right, done. Yes. Which part? And maybe then before you pass the gas sample, you measure the mass. Say this contains magnesium perchlorate. ClO4 twice. I measure the mass of this before I pass the gas. Say it is M1. After the passing gas, if the mass is M2, the M2 minus N1 is equal to the mass of CO2. So you will get the mass of CO2 from this. Got it? Understood? Yes or no? In the same way, we measure the mass of